It's working. Okay, great. So I will tell a little bit about me because my background actually is connected to the topic of this presentation. So I graduated from AGH, the University of Science and Technology in Krakow. Who is from AGH here? Okay, that's good university. I almost dropped on second year. I finished it, but I almost dropped because I was hired by Alvernia Studios. And I was hired as senior technical director, and basically I was driving the technology department there. So basically I was responsible there for designing and developing tools for creation of visual effects. So I was developing and programming tools that are used by artists to create explosions, smoke, fire, and simulations that you see in cinemas. And so, for example, here is a scene from Arbitrage movie with Richard Gere, and artists here were doing clouds. So the whole landscape of clouds that you see is artificial, and it's done using our tools 6 years ago. And basically, artists, the task artists had then was to create shapes of the clouds, was to define how the light behaves in the cloud, how the light behaves in how is subsurface scattering happening between particles in the clouds, and basically how you define how, for example, light behaves. So I guess you use some mathematical equations or programming languages. And the problem was, for a long time in the visual effects industry, that artists don't have the programming knowledge. So artists don't know how to program computers, don't know how to put their knowledge to machines and how to drive the machines to do what they want to do. However, they have the knowledge how computer graphics works. So they know how, for example, verticals, particles behave, what are polygons, and what are the differences between them, and what they want to achieve, but they didn't know how to do it. So visual effects studios, motion picture studios for years were hiring very pricey developers that were communicating with artists and were developing visual effects tools. So, and there was a big communication gap between these two groups because artists wanted to do something and programmers had to program that a little bit longer, but yeah. And the question back then was how to create something that will solve that problem. So how to provide artists with the power to create visual effects on their own, so how to give them powers of programmers without learning them to code. And the answer was, back then, something like that. Yeah, something like that. So, for example, on the screen you see right now a software that is called Houdini, and this software allows artists to process data simply by connecting visual components together. These components are like functions. So, for example, this component produces some data. This data goes to this component. It uses it and produces another data. And actually, when I was working in Alvernia, I was extending such tools and writing other components to control, for example, sand grains for sand simulations, components to define shapes, volumetric components, or how light scatters through clouds. And the problem with such tools still exists. They are widely used in gaming right now and visual effects industry. And the problem is that they are still severely limited because if you are provided with, let's say, 100 of nodes or 200 of predefined nodes, and of course they have got sliders and fancy widgets to control their behavior, you still are not using the full power that is available for developers. So a few years ago, I wanted to change exactly this situation. So after 3 years in Alvernia, I quit the job and started a startup here. Hey, how many of you are driving startup or working in a startup? Okay, I thought that even more, but yeah. So I founded a startup. It is named Flowbox, and the idea was simple: to create something like you have seen in Houdini, so the visual language that allows to process data by non-programmers without limitations. So every node that you put in stage is created out of other nodes. So if you double click on it, you go inside and you can go as deep as you want. So there are no predefined nodes, no limitations, and you can do anything you want with that. And we also had application in visual effects industry. So we wanted to create the next generation data processing language with applications in motion pictures studios. And here is one thing to learn if you are driving startup or if you are thinking about creating a company, that you have to be very, very precise about what you are doing. So if you want to create, for example, the next generation programming language with application in visual effects industry, these are actually two startups. And we have learned that over time. And I was in a very lucky situation because Mikołaj Valencia, who was my boss in Alvernia Studios, joined us in Flowbox after a year of our working, and we agreed that Mikołaj will take a lead in Flowbox, and I will quit and chase my dream of creating the perfect language for processing data. So Flowbox pivoted to be the best rotoscopy tool on market. Rotoscopy is some fancy word for describing processing images, tracking pixels and color correction and making some changes with that. And I started Luna. And okay, so yeah. For now, a few people here have thoughts. Okay, cool, that looks fancy, but how much it is connected to the topic of this presentation? And actually, it's very much connected, because if you are thinking about companies in today's world, they've got one big problem. Basically, we've got a lot of data, and data gathering is very easy thing. It is easy to a point that actually companies today have too much data. And the money, the real money, is behind the question how we extract valuable information from this data. And companies actually today have three main problems how to do it correctly. And so here we've got three axes: domain expertise, coding skills, and statistical knowledge. If you are thinking about data science or extracting data extracting knowledge from data, you have to cover all these axes. And the first problem companies today have is that the domain experts, so in visual effects industry, these are artists. In companies right now, these are people from almost all domains, like, for example, sales, production, finance, risk management, even HR. Right now, they are driven by data. And these domain experts are data illiterate. So data literacy basically means that we are able to read the data. We are able to understand the data. And today, in order to understand the data, we need to cover all these three areas. And basically, people that are domain experts and who can today, who could until today, yeah. So people who are domain experts in these areas and who could until today rely on their good feeling and experience right now have problem because they cannot handle the large amount of data that the companies have gathered. So yeah, it sounds similar to the visual effects industry. And the second problem is that, okay, if we've got, if our company has domain experts that are not able to process data on their own, but they know what they want to extract from this data, so we should hire data scientists. Data scientist is a person that actually is the second part. So he knows how to extract data, but normally they don't have domain expertise. If they have domain expertise and also all the other things, we call them unicorns. Yeah, and the problem right now with data scientists is that the demand for data scientists has grown sixfold over the last 5 years, and it will soar 28% in the next 2 years. And as we know, high demand lowers the necessary qualification of people that are accepted as data scientists, and as a result, we've got a lot of problems with, for example, people that are using wrong machine learning models or taking wrong decisions on results. And the last problem that companies struggle right now with is the communication gap between these two group of people. So when we are speaking with companies right now, a lot of companies put this problem as their biggest one. So in the result, the process is slow and it incurs high labor costs. So the idea how to solve this problem is actually very simple. So if we will be able to make data science much less technical than it is right now, and we will be able to bring 10 times more people to process data on their own, we will drastically progress as humanity. And actually, if somebody of you will find an answer how to do it, he will be or she will be very famous, because nobody knows the answer. I don't know if you have heard about who have heard about YC? Okay, so I will explain that maybe, because so YC is the most common, most known accelerator of startups in the world. It's based in San Francisco, and actually we've got a few companies here in Poland that were accepted to YC, like for example Estimate from Krakow, and even the founder of YC was a year ago in Estimate offices, and there was a meeting of OMGKRK with him. Anyway, YC is very, very known among all the startups around the globe. And YC Heart is a very interesting institution, because this is YC Human Advanced Research Center, and this institution is driven by Alan Kay. Alan Kay is the guy who invented object-oriented programming. Next to him is there also Brett Victor. Have you heard about Brett Victor? If not, then I really you should watch a talk that is 1 hour long, I think. It's Inventing on Principle. So Brett Victor is a human-computer interaction visionary, and it's talking how we as human will be interacting with machines in short future. Yeah, so. One more thing about how we are approaching this problem, because actually what we do, a lot of people believe that our approach, so what I and my company do is the answer for this problem. So we are creating a programming language that is useful by both developers as well as non-developers. So people that are from data science industry are able to create nodes, connect them with instant results visualizations, just interactively on a whiteboard. And this programming language has double representation. So if you are creating this graph, in fact, you are programming. So the code is actually automatically generated. But if you change the code, the graph is also updated. So this is very interesting approach, and when we presented it, for example, Guido van Rossum, the author of Python programming language, told us that this is the holy grail of computing. We've been speaking also with, for example, the author of R programming language 2 weeks ago, and he knew Luna, and also thinks that that what we do is the closest technology to a solution that he has in his head. So I strongly believe that if we as humanity are chasing a solution to a problem of data processing, we are right now missing a very important spot, because if you look at all the tools that are available on the market, there are two groups of tools that are user-friendly tools that allow you to visualize data, that allow you to process data, and there are code-based tools like all the Python notebooks, RStudio, Databricks tools, etc. However, there is an interesting spot that actually almost nobody is here, that are tools that are both programming languages and are also human user-friendly. And this is something that we strongly believe in, and not only us, as I just told you. For example, we have won also the Singularity University Global Impact Challenge this year, and my co-founder is right now in San Francisco in NASA Research Center, and yeah, he's having fun there. Yeah, and to show you more, about what I'm chatting about is I will play a video about how data processing looks in Luna, just to make this topic closer. My co-founder made this video just as a demo, so the sound will be from the video. And after it, I would love to chat with you about your ideas and about the problems that, for example, you are facing when processing data.
Hi, this is Marcin from Luna. Luna is a next-generation data processing platform based on a unique programming language with two equivalent representations, visual and textual. It opens up the possibility of achieving goals so far only possible with classical programming to people that can't work with code. Luna drastically speeds up the workflow and makes programming more accessible through extensive use of visualizations and friendly controls, instead of the standard code-based workflow. In this video, I'm going to show you how Luna is useful in banking. We will work with credit default risk data, performing exploratory data analysis, and building predictive models that can be used to get better insights and automate operations.
Can we for a minute
start by
dim the
loading
lights?
the data from my hard drive. Luna can work with many different data sources and formats, including local files, databases, and web APIs. Support for new data sources can easily be added by the users by reusing existing connectors from C, Python, or JavaScript. This is important because non-uniform data sources are very common in the industry. We then perform the data cleansing steps. Most data does not come in a form ready for further analysis. We need to understand its structure, clean and reformat it, and encode values in numeric formats, understandable for the machine learning models. This step alone often takes up over 60% of the data science workflow. Luna streamlines it by providing instant visual feedback, constantly giving us information about the shape and quality of data. Whenever we make a mistake, Luna provides us with cues about what went wrong and how to fix it. Unlike with traditional programming, the errors are displayed exactly where they occur, making debugging a blast. There is no need to scroll through lines and lines of code anymore. We get the relevant information right where we need it. At any point in time, we can select a subset of nodes and fold them into a single node, defining a new function. This is very useful for ensuring the right abstraction level of our workspaces and saving some screen real estate. More importantly, it enables code reuse, allowing us to automate workflows without the need to repeat all the steps every time. Such functions can later be shared with other collaborators and the open source community, providing a crowdsourced tooling base. Model training and evaluation is a very iterative process. Luna embraces experimentation and provides relevant information to enable rapid iteration. Different types of visualizations make it very easy to assess the model performance and select ones that best work for the particular problem. Trained models can be saved and later used to predict values for new observations, to automate many business processes, and speed up decision making. They can also become a part of a customer-facing application, providing great user experience. Everything you create with the visual representation becomes immediately available in code. Moreover, you can change the code, and the visual representation keeps track of those changes and reflects them. This allows you to mix and match both representations without breaking the workflow.
Yes, so yeah, that was just showed representation.
Thank you for watching. If you are interested in seeing how Luna can help you.
Yeah, so that was only the short presentation to show you what I was talking about, because it's hard to describe this kind of approach without showing how it behaves. But basically we believe that. Not only believe. When we introduce this to companies, then people that are right now using Excel or are data analysts are starting to process data on their own and are starting to take to behave like data scientists. And this is a very interesting approach regarding saving the companies in the future. So yeah, I wanted to keep the presentation short about possible gains from such approaches. So if you have any questions or want to chat about other possible ways of data processing and making companies more aware of data and aware of insights in the data, I would love to chat with you and answer some questions.